Hello friends, we are starting new session, a new topic, new unit, and that is on DC-DC converter. So in this, we'll have a quick review of basic chopper. So this DC-DC converter is popularly also known as chopper or DC regulated, you can say power supply. So a converter that converts fixed voltage DC into variable voltage DC is called DC-DC converter. And we can talk at length about why DC-DC converters are important. But at the same time, we are using DC-DC converter and not the conventional rectifiers because we assume over here that DC supply is already available, and then that is fixed DC voltage available, and we want variable voltage DC. So for that, DC-DC converters are used. The very common way of getting variable DC is that you use a transformer and then rectifier and then filter. But then that arrangement is a bulky and costly. While this DC-DC converters, which are popularly commonly used in all the applications which are listed over here, they are of very small in size and they're cheap also, and their performance is also superior, right? So let's see what is a chopper. Chopper, basic chopper, which is used as a switch, is discussed in this short video. Now you can see over here that a load is connected through a switch, where the switch over here is nothing but the power electronic switch. Here we can use BJT or MOSFET or IGBT as a switch. So the basic chopper is simply an on-off switch that connects and disconnects the DC supply to load at very fast rate. Now, what is this fast rate? Generally 1 kilohertz or so. Typically 1 kilohertz to 3 kilohertz is the switching frequency at which this is turned on and off, right? Now, how does it work? See, when the switch is turned on, when this is turned on, you can see the supply is available over here. So the output voltage is equal to Vs, right? You can see the waveform. There is voltage versus time, output voltage versus time. When the switch is turned off, there is no voltage. So we can see the output is 0. So for T on time, output is Vs, and for T off time, output is 0. And this is repeated in a cyclic manner at a very fast rate. What was the rate? It was almost more than 1 kilohertz. So this is the time interval, and this is going to be the switching frequency, which is in the range of 1 kilohertz or more. You can see the average DC which you get over here is in this fashion, and it is less than the supply voltage. So this is how we have achieved the variation in DC from fixed voltage DC. So this is how the cycle continues, and you get the variable DC. Of course, you can see over here, we are keeping the switch on and off for a particular period of time. So we get output voltage V0 less than the supply voltage. Okay, so now let's see how the output can be mathematically represented. So mathematically, we know that if there is this on and off for a particular period, then over the cycle, the average voltage is given by the formula 1 upon Ts integration zeros to Ts, the V0 T dt. Now, V0 T is varying with respect to time in two intervals. From 0 to T on, it is the constant voltage Vs, and from T on to T off, it is 0. So if the result of integration is that Vs comes out to be constant, and integration of 1 is T, and that is the limit from 0 to T on. So it comes out to be T on divided by Ts. This ratio T on over Ts is called the duty cycle ratio delta. So this delta or D is T on over Ts is the duty ratio. And this is the mathematical representation or mathematical relation between Vs and output voltage V0. We can see over here that this duty cycle delta is varying between 0 to 1. See, what is T on? You can have maximum T on as equal to the full on time. That is, T on is equal to the switching full interval Ts. So that will be delta is equal to 1. And if T1 is equal to 0, then you are going to get delta is equal to 0. So delta can vary between 0 to 1 only. And that's why the maximum V0 can be equal to Vs. Or otherwise, whenever delta is having value less than 1, V0 is going to be less than Vs only. So here, this is how a chopper is used as a switch to get reduced and variable output DC voltage. So by varying delta, variable DC output can be achieved. That is the main concept of DC-DC converter. Now here, when I am using basic chopper, it gives unregulated output. That means the voltage and current both are they are not smooth. They are in a pulsating form, as you can see over here. We have not assumed any inductor or capacitor connected for the filtering purpose. Now switch, as we have already discussed, that power BJT or MOSFET or IGBT can be used. Now depending on the requirement, if power requirements are more, IGBT should be preferred. If switching is to be high switching is required, MOSFET should be used. And in a moderate range, you use BJT where reasonable switching is there and power requirements are not very high, right? So this is how we can say the main concept, the core concept, the fundamental concept of getting variable DC from a fixed DC. Now in subsequent video, we are going to introduce the inductors and capacitor and see its effect, right? So then it becomes the regulator, right? So this is all about the first section of the DC-DC regulator. We have learned how it works as a chopper, right? So we'll continue with the same in our subsequent lecture.